Today I want to talk about this concept of differentiation being linear. Maybe you are like me and you hear this in Calculus 1 and are a bit confused. And the reason you're a bit confused is because in algebra, we sort of already have a definition of what a linear function is. And that definition is if we have a function like 2x plus 1 and we graph it, it's a line. So if we graph this function real quick, we know that our y-intercept is 1 and that our slope is 2. So go up 2 over 1. And so when we graph this, it looks like a line. So now let's look at another equation. Let's look at the equation y equals 1/3 x cubed. And let's take the derivative of this function. So we'll just use the power rule. So 1/3, we bring this 3 down and multiply it. And we reduce the power of our x by 1. So we find that the derivative of 1/3 x cubed is just x squared. And we know from algebra this graph is a parabola. So clearly when we say something like differentiation is linear, what we don't mean is when we take a derivative we always get a line. So what does it mean? Linear as it's being used here has a precise definition in linear algebra. For a function to be linear, basically there are two properties that have to hold true. So the two properties that have to hold true are, the first one being if we have f of x plus y, then whatever this equals is the same as if we just have f of x plus f of y. And the other property that has to hold true is if we have f of a times x, where a is just some constant. So think of it as like 2 or 3, or it could even be something like pi, just some number. And this has to be equal to if the constant was on the outside of the function. And that's it. So this linear algebra definition of linear just says if these two properties hold true for the function, then we have a linear function. So what does this mean for when we say differentiation is linear? So let me kind of talk about how this definition works for this concept. So let me just rewrite it. So that means if we have two functions, let's say we have a function f and a function g, that if we add f and g, so if we add the two functions together and we differentiate them, then it should be the same as if we took the derivative of f and we added it to the derivative of g. And for the other rule, what that means is if we take the derivative of x multiplied by some constant, let's say a, then this should be the same as taking a and multiplying it by the derivative of f of x. So let's see an example for how that would work. So let's say, and let's not go all the way, go to here. Let's say our function f was, let's just make this x squared. And let's say g was 3x. And so let's go ahead and check this first rule here. So we want to check that if we have f plus g and we take the derivative, then that equals, f prime plus g prime. Alright, so first, let me take the derivative. So we have x squared plus 3x, put that in parentheses, and then we want to take the derivative. And we don't know this yet, we're checking it, but this property of linearity says that this should be the same as taking the derivative of x squared and adding it to the derivative of 3x. So let's go ahead and take the derivative of this, again using the power rule. So we have 2x plus 3, and we're still checking this. And the derivative of x squared is 2x, and the derivative of 3x is just 3. So we do see that these are indeed equal. And then to check our second property, let's just use f of x. So what it says, if we take the derivative of a times x, and this is equal to a times the derivative of f of x. So let's let a equal 3. So f prime of 3 times, so let's have 3 times x squared, take the derivative, and then let's have 3 times the derivative of x squared. So when we take this derivative, again we're going to use the power rule, so we have 3 times 2 times x equals 3 times, and the derivative of this is 2x, and we see that these both equal 6x. And note that this is not a proof of this rule, but this is just an example to give you an idea of how this definition of linear works with differentiation. If you have any questions or comments, or if you think I made an error, go ahead and leave them below. Or if you have a different question you'd like for me to answer, send it to askalf0, the numeric 0, not the word 0, @gmail.com. And I hope to see you in my next video.